Okay, Trig, I'm at an appointment today with a kiddo, so I'm going to go, sorry, and jump right into chapter 1. Um, but we are finally in like page 15 now instead of our whatever. So we're in actual chapters now instead of the review chapters. Here's a homework assignment. If you need to pause it, you can go ahead and write those down. But today should be hopefully be pretty easy. And in fact, Casey and Addison, you guys are going to be like the top dogs today because we're doing distance and midpoint formula, which is what we just got done doing in geometry, or we've been doing like this whole time through, right? So you're going to definitely for sure know what's going on. This is going to be real easy for you, okay? So first thing that they address is talking about like the quadrants. So like when you're plotting points, like here's some points that are plotted. Hopefully you know how to plot points. And then quadrant 1, 2, 3, 4, they go around in that direction. And I always talk about why in trig because later on we will get to like putting angles in standard position. And standard position for an angle is going to have what's called an initial side, and then it's going to rotate around like this direction, right? And so this is something called the terminal side. And it rotates, though, in that counterclockwise rotation, 1, 2, 3, 4. And that's kind of why the quadrants are named that way, if you ever had any question why that was, okay? So distance and midpoint formulas, here is what we're talking about, like when we're talking about 2 points on a coordinate plane, 1, 5, and 4, 9. Now, if these were straight, like horizontal with each other, like from there to there, I would just count those. Or the same thing with a vertical line. I would just count those, right? But these ones, since they're at a slant, we have to actually do the distance formula. And what we're doing is with the distance formula, it's kind of like making it into a right triangle, right? And you're doing the Pythagorean theorem. So you're figuring out how many units are we in the x direction, which would be like your A side. How many units are we in the y direction? That would be like your B side. And then you can figure out how long side C is. So A squared plus B squared equals C squared. Now, since you're solving for C to get rid of the square, I would take the square root. So the distance formula is the square root of a squared plus b squared, okay? So I'm just going to do the distance formula with these two guys. What we're looking at here is square root a squared plus b squared. Now, there's a whole, like, this is what the distance formula actually looks like, and I never go to the work of, like, writing in x2 minus x1 and y2 minus y1, okay? I don't ever write those in there because I do that part in my head. It's way faster and all the things. So all I do is I look at the x coordinates and I say, how far apart are these two from each other, right? 1 to 4. That is 3 units, okay? Then I look at the y coordinates and I say, how far apart is 5 and 9? That is 4 units. Now, you might say like, oh, it's actually negative 3 units if you're starting at 4 and you're going to 1. But when you square it, that negative is going to turn positive anyway, so I never include any negatives when I'm doing my distance formula, okay? So 3 squared is 9, 4 squared is 16. That is the square root of 25, and that is 5. So this distance right here, let me erase all my junk. This distance right here is 5 units, okay? Now, it will not always come out nice, right? So we have to just, and in fact, most of the time it will come out as a decimal, but that's okay. All right, find the distance between these 2 points. We don't have to have them graphed. All we do is do the distance formula. We're looking for a squared plus b squared equals c squared, which is the square root part, okay? So I'm looking at how far apart is negative 5 and 7. You're going 12 units from there to there, negative 5 to 7. Think about it on the number line, 12 units. And then I'm looking at from 1 to 3. That is 4 units. Now, technically, you're going down 4 if you're going from negative 1 to 3. But again, I don't include that negative because it's going to end up squaring and being positive, okay? So this 12 squared is 144. 4 squared is 16. And if I add those together, that's the square root of 160. The square root of 160. And which is approximately 12.65 rounded to 2 decimal places, okay, because they wanted 2 decimals. So there's the distance between there. I hope I did that right. Okay, now example 2, determine if these vertices form the vertices of a right triangle. Whoa, go back. Form the vertices of a right triangle. Okay, now I'm like looking at this thing right here, and this is kind of a loaded question because you're like, how do I even know if it forms a right triangle? Well, I don't want to graph the thing. I don't. So what I'm going to do is I'm going to find the distances of the sides, okay? And this is kind of cumbersome because you have to find three distances. So I'm going to find the distance from M to P, then I'm going to do P to Q, then I'm going to do M to Q, okay? So I'm going to find those three distances, and we're going to figure that out, okay? All right, so M, I'm going to start with M. Wait a second, let me fill my, this guy squared plus this guy squared, this guy squared plus this guy squared, this guy squared plus this guy squared, okay? And I'm going to go, how far apart is -2 and 4, and that is 6. How far apart is -3 and 1, and that is 4. And 6 squared is 36, and 4 squared is 16, and that ends up being like the square root of 52. Now, just leave it as the square root of 52 for now, because I'm going to show you why here in a second, okay? Now, let me erase all my stuff. Now we're going P to Q. So we're going 4 to -1, which is 5. We're going 1 to 7, which is 6. Right? +1 to +7. This is 25 plus 36 is 61. So that's the square root of 61. Just leave it. Okay? Now we're going to do the last one, which is the first one to the last one. That is like here to here. So -2 to -1, that's 1 unit. From -3 to 7, that's 10 units. Okay? So 1 squared is 1, 10 squared is 100, and that ends up being the square root of 101. Okay? Now, I look at this and they want to know if it forms a right triangle. Okay, well, if it forms a right triangle, I can take the 3 sides and I can put them into a squared plus b squared equals c squared, right? Like that's how they work. But here's the problem though, I don't know which one is which, okay? The a and the b don't really matter, but I need to know what c is. C has to be my longest side. Oh, look. That has to be my longest side. The square root of 101 is going to be the biggest one, right? So I'm going to plug that in for C. This is the square root of 101 squared, the square root of 52 squared, plus the square root of 61 squared. Okay, let me check and make sure I didn't do anything wrong. I've got 6, I've got 4, I've got 5, I've got 6, I've got 1 and 10, and that is 52, and that is 61, and that is 101. All right, okay, there we go. So I'm just going to plug those guys in there. Now, when you are squaring a square root, those just go away. So 52 plus 61, I am checking to see if that one equals 100, 101, actually, because all of those squares and square roots will cancel out. 52 plus 61 is 113, which is not equal to 101. So that means this is not a right triangle. Okay, kind of a weird thing because like we used basically the distance formula, which is the Pythagorean theorem, to figure out the distance of each side. And then we used the Pythagorean theorem again to figure out whether it was a right triangle. So kind of an interesting method, okay? But that one is not a right triangle, okay? All right, the next one is midpoint. Finding the midpoint is like finding the average. I always say that. Finding the midpoint is like finding the average, right? If you're finding the middle of 2 points, you're finding the average between them, right? Okay, so how do I do the average if I have an x coordinate and a y coordinate, right? All you're going to do is you're going to average the x's, and then you're going to average the y's, right? So average means I add them together, and I divide by 2, right? And then the y's, I'm going to add them together, and I'm going to divide that by 2, right? Okay, so 4.2 plus a negative 2.8 is like 1.4, I think. 1.4, yeah. And 1.4 divided by 2 is going to be 0.7, okay? And then -4 plus 3 is a -1 divided by 2. If we keep them both in, and it's a negative. If we keep them both in decimal format, that would be -0.5. So there is my midpoint. That is my middle point, right? Now, you can graph these all day long if you want to and try to figure out the middle, but I'm guessing you're probably not going to guess that it's exactly at 0.7 comma -0.5. You're going to have to actually know how to do the midpoint, okay? Midpoint is average. That's it, okay? All right, next we have a couple graphing things. We probably will get done with these notes today, by the way. So this is going to be kind of a different thing because usually we're used to taking a couple days on each section. So sorry, kind of a long day, but it's you know, an easy thing, okay? Graph the equation by plotting points. I'm graphing this thing right here, and what I'm going to do is I'm going to throw this absolute value of x to the other side, okay? And he's going to be the absolute value of x plus 1. Now, probably some of you, if you remember from Algebra 2, know that what the parent function of an absolute value function looks like, right? Absolute value is a v. Okay, and maybe, I don't know, Casey and Addison, I didn't have you in Algebra 2, so I can't take credit for whether you know that or not, right? But an absolute value is a v, and then we got to figure out what this plus 1 is doing, right? The plus 1 is going to move him up 1. So he's going to be a perfect v at a 45-degree angle this way, and at a 45-degree angle this way. That's what absolute value looks like. So he's really like a 90-degree angle in the middle. That's what absolute value looks like, but he's up 1. Now, they did not want us to do it that way. They wanted us to plot points, okay? I don't care which way you do it. If you know the parent functions and you want to go ahead and graph it, that's totally fine to me, right? But what I'm going to do is I'm going to do like -2, -1, 0, 1, and 2, right? And then I'm going to plug it into this equation right here. So I'm plugging each one of those in, all right? So if I plug -2 in, the absolute value of -2 is 2, and 2 plus 1 is 3, right? So -2 should be at +3. There's that dot, right? If I plug in -1, absolute value of -1 is 1, and 1 plus 1 is 2, so -2, or -1 is at 2. Like, just like we said. 0, the absolute value of 0, 0, 0 plus 1 is 1, so that's at that dot, right? If I plug 1 in, it will be the same, so it'll be at 2 and at 3, and that's those dots, and then you just keep going with your arrows, okay? I usually do -2 to 2. If you want to go a little bit further, you could go -3 to 3, whatever. I usually try to do some positives and some negative values, just to see how that works, okay? All right, now, let's go to this one right here, okay? I'm going to leave it written like this, okay? This is the function x equals y squared minus 1, right? If I flip them around. Now, you guys, even though you took Algebra 2 with me, may not know what that looks like, or maybe you do, I don't know. But I'm going to think about like what y equals x squared minus 1 looks like. X squared is a parabola, and the minus 1 is going to move him down 1, right? So he looks like this, okay? But this one is going to be a parabola on its side, and the minus 1 is going to move him to the left one, right? So he's going to look like this. Zoop, zoop. Okay, you can go ahead and draw that. We're going to do a table here in just a second. So if you didn't know that already, we'll do a table. And, oh, and the reason why it's left one, like most of the time you're looking at this and you're like, that means down 1. Well, it means down 1 if it's y equals, right? But the fact that it's x equals means it's to the left one, right? Now, I'm going to do x and y. And because this guy is set up so x equals y, I'm going to treat y as my input variable, okay, just for now. I'm going to treat him as an input variable, and I'm going to do -2, -1, 0, 1, and 2 on my y coordinates, right? Because everything is set up to equal x, which is kind of a foreign thing, all right? So if I do -2 and I square that, if he's in parentheses, that's +4, and 4 minus 1 is 3. So -2, wait a second. -2 is the y coordinate, so 3 and -2. 3, -2, right there, okay? -1, if I plug -1 in, -1 squared minus 1, that'll be 1 minus 1, so 0, -1 is where I'm looking at. 0, -1. My graph is kind of crappy, but whatever, okay? If I plug in 0, 0 squared is 0, minus 1 is -1, so I'm at -1, 0. There he is. If I plug in +1, 1 squared is 1, minus 1 is 0, and then I'm going back to 3 again, okay? So 0, 1, and 3, 2. He should be down a little bit lower. 3, 2 is right here. So my parabola is a little high, but there you go. Okay, so that's what he will look like by plotting points, all right, if you didn't already know that. And the parent functions, if you do know that, you can go ahead and graph them by the parent functions, I don't care. We will learn those actually this chapter. We'll talk about transformations and parent functions. So Addison and Casey, if you don't know those, that's totally fine. We will get you caught up to speed, okay? That's example 5. Let's go to example 6. We're talking about x and y intercepts, okay? So I'm going to give you a little rundown of x and y intercepts. Let's talk x-intercept first. This is the x-axis. This is the y-axis, all right? This right here is an x-intercept. Let's say he is at 3, 0. This guy is, let's say, -2, 0. This guy is, let's say, -7, 0. If we're looking for the x-intercepts, the thing that they all have in common is that the y-coordinate is 0. So if I'm trying to find the x-intercepts, I'm going to plug 0 in for y, right? If I'm looking for y-intercepts, so let's say we go back over here. Let's say we have this point right here, which is 0, 1. Let's say we have this point right here, which is 0, 5. Let's say we have this point right here, which is 0, -4. All of those have in common the fact that the x coordinate is 0. So I'm going to plug 0 in for x. If I'm trying to find the y-intercepts, I plug 0 for x. If I'm trying to find the x-intercepts, you plug 0 for y, right? Okay, so over here, I'm trying to find the x-intercepts, okay? Now, and I'll go back up to this box here in just a second. Find the x-intercepts. I'm plugging 0 in for y. So I go 0 equals absolute value of x minus 1. All right, when we're solving absolute values, remember, isolate the absolute value. So I'm going to add the 1 over, right? So 1 equals the absolute value of x. And then he's still an absolute value, so I'm going to have two cases, right? The first one is that 1, if you don't like this, I'm going to switch it around. Absolute value of x equals 1. I'm going to switch it around, okay? So I have x equals 1, and then I have negative x equals 1, right? Or x equals negative 1 if I divide. Those are going to be my two answers, right? Find the x-intercepts, okay? X-intercepts where he crosses the x-axis are at 1 and negative 1. Got it, okay? Now I want the y-intercept, which means I'm going to plug 0 in for x. So I've got this thing going on, right? The absolute value of 0 is 0 minus 1. The y-intercept is negative 1. So I've got this little dot right here, and he is a v because he's an absolute value, right? He's a perfect v. He's not a parabola. Parabola would be x squared. That's your parent function. X squared looks like a parabola. Absolute value looks like a v, okay? So there is that. Now, here's the deal. I'm going to go back up to this box, find the x-intercepts by, oh, never mind. I thought they were going to tell something different than that. By substituting 0 in for y, 0 in for x for the y-intercepts. I thought that box was going to say something different, and it is this. If it is a function, you will only have one y-intercept ever, but you may have multiple x-intercepts. So typically when you're doing this, finding the y-intercepts is easier because you only have one of those. You may have more than one x-intercept though. Okay, I thought that's what that box was going to talk about, but whatever. Okay, all right, last thing. We're going to have to wait because we have to have your graphing calculators, and I want to show you on your graphing calculator. I can't show you on your graphing calculator. So skip 7. And if there's a homework problem that's like that, just hold off on that one, and we'll answer that question on Monday when we come back to school. But I can't show you the viewing window. I can't show you how to graph those. You might be able to, but then changing the window to those, I'll show you how to do that on Monday. So remind me, we'll do that Monday. If there's a homework assignment, skip that one till Monday, but do the rest of them. There you go. There's homework. Goodbye.